Northern France, February 15, 1944.1300 hours. Oberleutnant Hans Vera Lurch observed 8 Republic P-47 Thunderbolts coming from the west at 23,000 feet. Their contrails stretched across the winter sky like white fingers, reaching towards his Messerschmitt Bf 109 G6. Formation of fighters from Jagdgeschwader II had been vectored to intercept what ground control described as just another routine bomber escort mission, the sort they had grown increasingly confident in handling since the Americans introduced their massive P-47 the previous spring. Then the lead American fighter did something that sent a chill down his spine, something that defied everything he knew about the 7-ton American fighter. Something that would mark this day as the moment the Luftwaffe realized their once comfortable advantage had slipped away. The Thunderbolt not struggle climbed at an angle that should have been impossible for such a massive American fighter. Its Pratt & Whitney R2800 double Wasp engine screamed with a sound he had never heard before, a howling noise that spoke of unleashed power, accompanied by wisps of what appeared to be steam trailing from the exhaust stacks. Lurch knew instantly that something had fundamentally shifted in the air war over Europe. For nearly a year, Luftwaffe pilots had developed a standard escape tactic against the Thunderbolt. They would simply pull into a steep climb, knowing the American fighter couldn't follow. They relished watching the frustration as their heavy fighters wallowed and stalled, unable to match the German climb rates. It had worked flawlessly mission after mission, allowing German pilots to bounce American formations from above, take quick shots, and zoom climb to safety while the Thunderbolts struggled to keep up. But now Lurch watched in disbelief as the lead Thunderbolt, marked with the distinctive checkerboard nose of the 78th Fighter Group, maintained its climb angle, matching his Messer's performance meter for meter. The massive radial engine produced a sound unlike anything he remembered. A deeper, more violent roar that sent a cold shiver down his spine. If you're enjoying this deep dive into the story, hit the subscribe button and let us know where you're watching from today. Major Wolfgang Fall, leading the second group of German fighters, had been flying combat missions since the Battle of Britain. He had faced Spitfires, Hurricanes, Soviet Yaks and La-GGs, American P-38 Lightnings, and P-51 Mustangs. But the P-47 had always been predictable, a brute-force bomber escort that could dive like a falling safe, but climbed like a pregnant whale. German pilots had learned to exploit this weakness ruthlessly, using their superior climb rates and maneuverability to ambush American formations, then escape vertically when things got dangerous. A tactic that had worked flawlessly for nearly a year. But as Fall watched his wingman climb steeply with a P-47 clinging to his tail, matching his angle of ascent, he realized their comfortable tactical advantage had suddenly evaporated. The American fighter maintained its pursuit through maneuvers that should have left it stalled and vulnerable. The engine note shifted to something almost supernatural. The transformation of the P-47 Thunderbolt hadn't happened overnight, though it felt that way to the German pilots now confronting a radically different opponent. Since late 1943, American engineers at Republic Aviation and Pratt & Whitney had been working tirelessly to address the Thunderbolt's notorious climb deficiency, installing a water-methanol injection system, ADI, that sprayed a 50/50ths mixture of water and methanol directly into the supercharger. The system cooled the compressed air charge and prevented detonation, enabling the R2800 engine to produce 2,800 horsepower instead of its usual 2,000, a 40% increase in power that transformed the aircraft's performance. Combined with new Hamilton standard hydrostatic paddle blade propellers with broad 13-foot, 1-inch diameter blades that bit into the air with unprecedented efficiency, the Thunderbolt's climb performance was transformed. These improvements would have fascinated German engineers had they known the full story. The ADI system injected the water-methanol mixture at approximately 6 gallons per minute directly into the General Electric C-23 turbosupercharger. The water absorbed heat through evaporation, while the methanol, with its 110-octane rating, acted as an anti-detonant, allowing higher manifold pressures without damaging the engine. The mixture cooled the intake charge by 25 to 40 degrees Fahrenheit. The methanol's lower boiling point of 148.5 degrees Fahrenheit caused it to vaporize almost immediately, providing both charge cooling and extra fuel energy, allowing the engine to operate at 70 inches of mercury manifold pressure instead of the normal 52. 56th Fighter Group at Bogstad had been the first to receive the modifications in January 1944, with Lieutenant Colonel Francis Gabreski noting in his combat reports that German pilots who had previously escaped by climbing were now finding Thunderbolts following them into steep climbs, maintaining pursuit angles that would have been impossible just weeks before. The water injection system gave 5 minutes of war emergency power, transforming what pilots called the Jug into a climbing monster. Word spread quickly. Quickly, the news spread through the Luftwaffe. Something had changed with the American fighters. Although many German pilots initially refused to believe the reports, assuming pilot error or exaggeration until they experienced it firsthand. Feldwebel Kurt Bulligan of Jagdgeschwader II had shot down 2 P-47s in late 1943, using the standard tactic of attacking from above, making a high-speed firing pass, then zooming away while the American fighter struggled to follow. However, on February 14, 1944, the day before Lurch's encounter, Bulligan had bounced a formation of Thunderbolts near Cambrai. He made his attack run on a trailing American fighter, scoring hits on the engine cowling, then pulled into his escape climb, only to see the damaged Thunderbolt following him up. The American pilot pushed the throttle to its last eighth of an inch, activating the water injection system. The engine's note changed from the usual roar to what Bulligan later described as the sound of an enraged god. He watched his airspeed indicator drop as the massive American fighter somehow maintained the climb angle, forcing him to level off and attempt to escape in a dive, where the Thunderbolt's weight advantage made it even more dangerous. The new paddle blade propellers alone would have been a significant improvement. Republic test pilot Lowry Brabham discovered, during initial flights with the Hamilton Standard hydrostatic propellers in December 1943, that the broader 13-foot diameter blades provided dramatically better thrust at all altitudes, especially in climbs where the older Curtiss electric props had been inefficient. The new blades added 400 feet per minute to the Thunderbolt's climb rate even without water injection. But combined with the ADI system, the result was transformational, creating a nearly new aircraft while retaining the familiar Thunderbolt shape. Halderman Heinz Baer of Jagdgeschwader I, one of the Luftwaffe's most successful aces with over 200 victories, encountered the upgraded Thunderbolts on February 23, 1944, while leading a swarm of Focke-Wulf 190s on a bomber interception mission near Frankfurt. He watched as 4 P-47s from the 4th Fighter Group dove on his formation in the standard American attack pattern. When Baer ordered his pilots to break into climbing spirals, the traditional escape maneuver that had always left Thunderbolts behind, he was stunned to see the American fighters following them up, maintaining pursuit angles that would have been impossible just weeks earlier. He was forced to order his pilots to split up and escape individually. Later, in his combat report, Baer wrote that the Americans had somehow given their heavy fighters the climb performance of a Messerschmitt. The transformation wasn't without initial problems. The first P-47 units to receive water injection in the European theater experienced numerous failures when ground crews mistakenly filled the 80 tanks with the wrong mixture, using 30% isopropyl alcohol instead of the required 50% methanol due to supply confusion. This caused engines to detonate and fail during combat. In response, Pratt & Whitney sent engineer Bill Claus to England in February 1944 to resolve the issue. He discovered that many crew chiefs didn't fully understand the critical importance of the mixture ratio. That methanol wasn't just antifreeze, but a crucial component that provided both cooling and anti-detonant properties while adding energy to the combustion process. Lieutenant General Adolf Galland, commanding the Luftwaffe's fighter forces, began receiving increasingly alarming reports from his squadron commanders about the transformed American fighters. Initially, Galland dismissed these as excuses for poor performance until he witnessed it firsthand during an inspection visit to JG-26 at Le Havre in March 1944. There, watching a training demonstration where veteran pilots tried to show younger pilots how to exploit the Thunderbolt's climb weakness, Galland saw a patrol of P-47s spot them and give chase. The American fighters followed the Messerschmitts into a steep climb that should have been impossible. Galland, observing through binoculars, saw the massive American fighters maintain pursuit angles that defied everything German intelligence had reported about their capabilities. Major Gay AFJG-11, who would finish the war with 275 victories, encountered his first water-injected Thunderbolt on March 3, 1944, while attacking a formation of B-17 flying fortresses near Berlin. After diving through the bomber formation and expecting to escape the escorting fighters by climbing away on the other side, a tactic that had worked countless times before R pulled up from his attack run, but a P-47D-23 from the 359th Fighter Group stayed with him. The American pilot pushed his throttle into war emergency power, the water-methanol mixture cooling the charge air as the engine screamed at 2,800 horsepower. Forced to push his Messerschmitt into a desperate series of violent maneuvers to break free, R used every trick learned in 4 years of combat to escape the suddenly predatory Thunderbolt. At 36,000 feet, 10,000 feet above the Focke-Wulf 190s below, R attacked and claimed a Thunderbolt, but was soon ambushed by more P-47s. As R dived to escape, his Bf-109 could not outdive the Thunderbolts, which attacked him relentlessly, preventing him from turning left or right. R was flying at nearly 620 miles per hour, but his aircraft was hit in the engine, leading to further complications. The transformation of the Thunderbolts quickly became evident throughout the Luftwaffe. Initially, many German pilots were skeptical, dismissing reports as pilot error or exaggeration until they faced the new American fighters themselves. Feldwebel Kurt Bulligan of Jagdgeschwader II had shot down 2 P-47s in late 1943. Employing the standard tactic of attacking from above, making a high-speed pass, and zooming away as the American fighter struggled to follow. However, on February 14, 1944, the day before Lurch's encounter, Bulligan attacked a formation of Thunderbolts near Cambrai, making his strike on a trailing P-47. After hitting the engine cowling, he pulled into his escape climb, only to see the damaged Thunderbolt following him up. The American pilot pushed the throttle into war emergency power, activating the water injection system. Bulligan described the engine's note changing to a sound like an enraged god as the Thunderbolt suddenly accelerated in the climb. His airspeed indicator dropped as the P-47 maintained its climb angle, forcing Bulligan to level off and dive away, where the Thunderbolt's weight advantage made the situation even more dangerous. The new paddle blade propellers alone would have been a major improvement. Republic test pilot Lowry Brabham discovered in December 1943 that the broader 13-foot diameter blades of the Hamilton standard hydrostatic propellers provided better thrust at all altitudes, particularly in climb where the older Curtiss electric props had been inefficient. These new blades added 400 feet per minute to the Thunderbolt's climb rate, even without the water injection. But combined with the 80 system, the performance was transformed, effectively creating a new aircraft under the familiar Thunderbolt shape. Halderman Heinz Baer of Jagdgeschwader I, one of the Luftwaffe's most successful aces with over 200 victories, first encountered the upgraded Thunderbolts on February 23, 1944. While leading a formation of Focke-Wulf 190s on a bomber interception near Frankfurt, Baer's pilots were taken by surprise when 4 P-47s from the 4th Fighter Group attacked in their usual pattern. After ordering his pilots to break into climbing spirals, the traditional escape maneuver, Baer was stunned to see the American fighters following them up, maintaining pursuit angles that should have been impossible only weeks before. He was forced to order his pilots to split up and escape individually. In his combat report, Baer noted that the Americans had somehow given their heavy fighters the climb. Performance of a Messerschmitt. The change wasn't without its challenges. The first P-47 units to receive water injection in the European theater experienced failures when ground crews mistakenly filled the 80 tanks with the wrong mixture, using 30% isopropyl alcohol instead of the required 50% methanol, leading to engine detonation during combat. In response, Pratt & Whitney sent engineer Bill Claus to England in February 1944 to resolve the issue. Claus discovered that many crew chiefs did not fully understand the importance of the correct mixture, unaware that methanol was not just antifreeze but a vital component for cooling, preventing detonation and boosting engine power. Lieutenant General Adolf Galland, commanding the Luftwaffe's fighter forces, initially dismissed the increasing reports about the transformed Thunderbolts. However, after witnessing the change himself during an inspection of JG-26 at Le Havre in March 1944, he recognized the problem. Galland observed a demonstration where veteran pilots attempted to exploit the Thunderbolt's climb weakness, only to have their plans backfire when a P-47 squadron spotted them and gave chase. The Thunderbolts followed the Messerschmitts into a steep climb, maintaining pursuit angles that defied all previous intelligence. Major G.R. of JG-11, who had finished the war with 275 victories, encountered his first water-injected Thunderbolt on March 3, 1944, during an attack on a formation of B-17 flying fortresses near Berlin. Expecting to escape the American fighters by climbing away after diving through the bomber formation, something that had always worked before, was shocked when a P-47D-23 from the 359th Fighter Group stayed with him. The American pilot activated the war emergency power, and R had to use every combat maneuver in his arsenal to escape, but the Thunderbolt kept up. At 36,000 feet, R attacked and claimed a Thunderbolt, but soon found himself ambushed by more P-47s. R tried to dive away, but his Messerschmitt could not outrun the Thunderbolts, which continued to harass him. His aircraft was eventually hit in the engine, forcing him into a desperate situation. The psychological impact on German pilots was perhaps even greater than the tactical implications. The advantage they had enjoyed over the P-47 evaporated almost overnight. Pilots who had once treated Thunderbolts as easy targets now found themselves pursued by fighters that could match them in climb, outdive them dramatically, and absorb tremendous damage while delivering devastating firepower from 8.50 caliber machine guns. This coincided with the arrival of more experienced American pilots who had learned to maximize their aircraft strengths, further shifting the balance of air superiority over Europe. OBERFEL DWEB L. Hermann Graf, a veteran ace from JG-52 with over 200 victories, transferred from the Eastern Front in February 1944, expecting the Western Front to be equally productive. However, his first encounter with the upgraded Thunderbolts on February 28 nearly ended in disaster. Graf bounced what he thought was a vulnerable P-47 straggling behind its formation, only to see the American pilots slam the throttle forward and engage the water injection. Graf described the engine's note changing to a banshee-like wail as the Thunderbolt suddenly accelerated in its climb. Graf's Messerschmitt barely escaped by diving away at maximum power. Later, he admitted that he had never seen any fighter climb with such violent authority. The Germans had tested their own version of water-methanol injection systems for their BMW 801 radial engines, but due to production issues and the system's complexity, it had seen limited deployment. The Americans, on the other hand, managed to implement the system across their entire P-47 fleet in a matter of months, retrofitting older aircraft in the field and equipping new production models with the system already installed. This demonstrated the superiority of the American industrial capacity, which the struggling German war economy could not match. Even when they understood the technology, on March 11, 1944, Major Adriano Visconti of the Italian Social Republic's Air Force, the Aeronautica Nazionale Repubblicana, led his Mach-E C-205s against a mixed formation of American bombers and escorts. The Italian pilots were confident their nimble fighters could outmaneuver any American fighter, but Visconti was shocked to see a Thunderbolt he expected to leave behind in a climb stay with him. The American pilot engaged the water injection, forcing Visconti to abandon his attack and dive away. Similarly, Sergeant Major Luigi Guarini, flying with the Primo Gruppo Caccia, had claimed 3 P-47s in 1943 using the Mach-E C-205's superior climb rate and maneuverability. But on March 18, 1944, during another mission, Guarini found himself pursued by a P-47D-22. The American pilot activated the water injection, maintaining the climb while Guarini struggled to keep up. Forced to roll inverted and dive away, Guarini reported that the Americans had transformed their heavy fighters into something entirely different. German technical intelligence had captured a damaged P-47 in November 1943 when Second Lieutenant William E. Roach of the 355th Fighter Group made an emergency landing at a Luftwaffe airfield. The P-47D-2, serial number 422490, spent the remainder of the war in the German collection of captured Allied aircraft. But this aircraft predated the water injection modifications. As a result, German engineers had no warning of what was coming. Even if they had known, the German aviation industry was already struggling to maintain production under increasing Allied bombing and had no capacity to develop similar systems for their own fighters. Consequently, Luftwaffe pilots were forced to face the transformed Thunderbolts with aircraft that suddenly seemed obsolete. Major Wilhelm Hoffmann of JG-3, based at St. Quentin, had developed specific tactics for engaging P-47s based on their known weaknesses. His pilots were trained to attack from above, make one firing pass, and escape in a steep climb that the heavy American fighters could not match. However, on March 8, 1944, during an interception of B-24 Liberators with P-47 escorts from the 355th Fighter Group, Hoffmann watched as his tactics disintegrated. The Thunderbolts displayed climb performance that matched his Messerschmitts. Hoffmann's pilots called out an alarm over the radio as the American fighters that should have been lagging behind maintained pursuit. The new water injection system screamed as the big Pratt & Whitney engines delivered power levels that completely transformed the tactical situation. Johann Steinhoff, commanding JG-77 in northern Italy, was among the first to receive reports from pilots who had encountered the upgraded Thunderbolts during engagements with the American 12th Air Force in March 1944. Initially, many German pilots refused to believe that the P-47s were matching the Messerschmitt Bf 109 G-14s in climb performance until Oberst Johann Steinhoff led a mission on March 15th, attacking American fighter bombers near Bologna. To his surprise, he found himself pursued by a P-47D-27, whose pilot activated the water injection and followed Steinhoff's aircraft into a climb that should have been impossible. The German ace was forced to use every trick of his considerable experience to escape, later reporting to Luftwaffe headquarters that the Americans had somehow eliminated the Thunderbolt's primary weakness overnight. The water-methanol mixture consumption rate was approximately 6 gallons per hour at war emergency power, with most P-47s carrying 15-gallon tanks that provided around 5 minutes of maximum boost. This was enough for critical combat situations but required careful management, as pilots had to judge when to use their limited supply. This led to new tactical doctrines that emphasized saving the water injection for decisive moments, either to escape when bounced or to maintain pursuit of a climbing enemy. The system quickly became as much a psychological weapon as a technical one, as German pilots could no longer tell which Thunderbolts had already expended their water supply and which still had 5 minutes of monster performance available. The mechanical reliability of the water injection system initially concerned American crew chiefs, who worried about the added complexity and potential failure points. However, Pratt & Whitney engineers had designed the system with military ruggedness in mind, using simple pressure injection rather than complex metering systems. The water-methanol mixture was stored in protected tanks with heated lines to prevent freezing at altitude. The system was activated by pushing the throttle past a mechanical gate into the last 8 inches of travel, ensuring it worked when needed while preventing inadvertent activation. During normal flight, on April 25, 1944, Colonel Mario Bellegami, commanding the INR's Quinto Gruppo Caccia with Fiat G-55 Centauros, led a formation against American bombers near Bologna. It was the last major engagement before Allied bombing destroyed the Fiat production facilities. Bellegami encountered P-47D-3OS from the 325th Fighter Group, whose pilots immediately engaged the water injection when the Italian fighters appeared. The Thunderbolts climbed to match the Centauros meter for meter, while their 8.50 caliber guns created a devastating cone of fire. Bellegami lost 3 aircraft, including his wingman, before escaping. The surviving Italian pilots reported that the American fighters displayed impossible performance that had not been anticipated by their intelligence reports. Major Erich Hartmann, the Luftwaffe's highest-scoring ace with 352 victories, primarily flew on the Eastern Front but transferred briefly to JG-53 in Romania in April 1944. There, he encountered P-47Ds from the 15th Air Force, escorting bombers attacking the Ploiesti oil facilities. Hartmann expected the American fighters to be easy prey compared to Soviet Yak-9 South and Lavokin La-5 South. But instead, he found that the Thunderbolts exhibited climb performance that exceeded anything he had encountered. One particular P-47D-28 pursued Hartmann's Messerschmitt through a series of vertical maneuvers that should have been impossible for the heavy American fighter. Hartmann escaped only through superior tactical positioning and experience. He later commented that the Americans had somehow transformed their flying tanks into rocket ships. The Allied bombing campaign against German aircraft production facilities prevented the Luftwaffe from developing or deploying countermeasures, even when they understood the technology. Messerschmitt factories in Regensburg and Augsburg were under constant threat, while BMW's engine plants struggled to maintain production of existing designs, let alone develop water injection systems for the BMW 801 radial or Daimler-Benz 605 inline engines. This left German pilots to face the transformed American fighters with aircraft whose performance advantage had evaporated, forcing them to rely increasingly on tactical skill and experience against opponents who now had both superior numbers and comparable performance. The production statistics tell the strategic story. Republic Aviation manufactured over 15,000 Thunderbolts, more than any other American fighter. Meanwhile, Curtiss-Wright and Ford added thousands more under license. The massive American industrial base allowed for the rapid implementation of the water injection and paddle blade propeller modifications across the entire fleet. In contrast, German aircraft production struggled under Allied bombing, shortages of strategic materials, and the loss of experienced workers to military service. The Luftwaffe was forced to face ever-increasing numbers of transformed Thunderbolts with diminishing resources and increasingly inferior equipment. This reached its climax in the final months of the war, when German pilots flying the ultimate variants of their fighters, Bf 109K4 South with DB605D engines producing 2,000 horsepower, FW 190D9S with Junkers Jumo 213A engines, and even Te-152H high-altitude fighters found themselves unable to establish superiority over Thunderbolts that had been transformed from sluggish bomber escorts into apex predators. The water injection and paddle blade propellers eliminated the performance gap that German pilots had relied upon, forcing them to engage in battles where only tactical skill mattered, and where American numerical superiority made the outcome inevitable. Major Herbert Ehrfeld, commanding the first group of Jagdgeschwader 11, led one of the last major Luftwaffe fighter operations against American bombers on March 18, 1945. He assembled every available Messerschmitt and Focke-Wulf for maximum effort against a heavily escorted American bomber formation. But even this final attempt could not overcome the transformed Thunderbolts in the spring of 1945. As B-17s attacked Berlin, German pilots encountered P-47Ds from the 56th Fighter Group, whose pilots had been using water injection for over a year. These pilots had mastered the capabilities of the transformed Thunderbolts, and the German fighters could only watch helplessly as the American fighters, once thought vulnerable in climb, pursued their every escape maneuver. The water injection systems allowed the P-47s to maintain pursuit angles that would have been impossible just 18 months earlier. Major Herbert Ehrfeld, leading the Luftwaffe formation, lost 6 aircraft without shooting down a single bomber. This mission effectively marked the end of organized Luftwaffe resistance. In November 1944, Oberleutnant Walter Noten, commanding Kommando Noten equipped with the revolutionary Me-262 jet fighter, observed Thunderbolts operating over his airfield at Akma. He noted that even his advanced jet fighters had to respect the transformed American aircraft. The P-47's water injection systems allowed them to accelerate in climbs, catching a Me-262 pilot who made the mistake of climbing away at insufficient speed. Noten himself nearly found himself caught by a P-47D-30, whose pilot activated the water injection and briefly maintained pursuit of the jet. Noten managed to escape only because the Thunderbolt's 5-minute water supply was exhausted before it could. Close to firing range, despite initial concerns that the additional power would drastically reduce engine life, the effect of the water-methanol injection system on engine wear was surprisingly minimal. Pratt and Whitney engineers discovered that the water-methanol mixture actually reduced peak combustion temperatures, even with the higher power output. The cooling effect protected the valves and pistons from heat damage, allowing combat operations at 2,800 horsepower with acceptable reliability. Crew chiefs were, however, instructed to monitor engines that had used water injection extensively, checking for signs of detonation, damage, or bearing wear. The legacy of the transformation of the P-47 Thunderbolt extended beyond combat statistics, fundamentally changing how military aviation approached performance enhancement. The water-methanol injection system proved that chemical intercooling could provide performance gains equivalent to major engine redesigns. The paddle blade propeller underscored the importance of matching propeller design to specific performance requirements, rather than settling for compromise solutions. These lessons influenced military aircraft development for decades after the war. In the final analysis, the transformation of the P-47 Thunderbolt through water injection and paddle blade propellers was more than a technical achievement. It marked a turning point in the air war, where American industrial capacity and engineering innovation overcame Axis technical superiority. This was the moment when quantity achieved quality through systematic improvement. German pilots, who had developed carefully honed tactics, suddenly found them obsolete. Their once comfortable advantage had vanished in a cloud of water-methanol vapor and the roar of 2,800 horsepower. The sleeping giant of American air power had awakened with a vengeance, sweeping Axis from the skies. On April 26, 1944, Major Giovanni Bonetti of the ANR's 10th Fighter Group, one of the few Italian units to receive Messerschmitt Bf 109 G10s from Germany, engaged P-47Ds near Milan, the day after Mussolini's execution and 2 days before the German surrender in Italy. Leading 4 fighters in one of the last Axis fighter missions in the Mediterranean theater, Bonetti encountered Thunderbolts from the 57th Fighter Group, whose pilots immediately activated water injection upon seeing the Messerschmitts. The American fighters displayed climb performance that Bonetti couldn't believe, and his German-supplied fighter was unable to escape. Bonetti was saved only by the intervention of German flak batteries, which forced the American pilots to break off their pursuit. The technological revolution represented by the water injection and paddle blade propellers reflected a fundamental difference in industrial capability and engineering philosophy. The Americans were able to identify a weakness, develop a solution, and implement it across thousands of aircraft in a matter of months, while the Axis powers struggled to maintain production of existing designs. Their engineers understood the technology but lacked the resources to implement it, forcing their pilots to face transformed opponents. With aircraft that suddenly seemed obsolete, the balance of technical superiority shifted decisively to the Allies just as the air war reached its climactic phase. Captain Robert S. Johnson of the 56th Fighter Group, who would finish the war as one of the leading American aces in Europe with 27 victories, flew a specially prepared P-47D5 nicknamed Lucky, which his crew chief, Pappy Gould, had modified with assistance from factory technical representatives. The aircraft had been sanded smooth, waxed to a high gloss, and its wastegates adjusted to maintain higher boost pressure than normal. Though Johnson claimed he never used the water injection in combat because he didn't need it, he occasionally activated it for the thrill of it. By pushing the throttle up to 72 inches of manifold pressure, he could feel the headrest smack him from behind as the big fighter surged forward with impossible power. Johnson would let it run for a few minutes, watching the airspeed indicator climb past 300 miles per hour at 32,000 feet. By the summer of 1945, the P-47 Thunderbolt had become a force to be reckoned with, surpassing the expectations of all who faced it. With its B-Series R2800 engine, the Thunderbolt achieved nearly 470 miles per hour true airspeed, outpacing the official specifications by nearly 60 miles per hour. This performance made it virtually impossible for German pilots to match or escape. The Japanese Navy also had their first taste of the transformed Thunderbolt when they encountered P-47NS over the home islands in July 1945. Lieutenant Commander Minoru Genda led 12 fighters against what he assumed would be lumbering American escorts, only to find the Thunderbolts displaying performance that exceeded their intelligence reports. The American fighters climbed with authority while maintaining speeds his aircraft couldn't match. The water injection systems allowed them to pursue through maneuvers that should have left the Thunderbolts stalled and vulnerable. Genda lost 4 aircraft before he ordered a withdrawal, later commenting that the Americans had somehow given their fighters supernatural capabilities that defied logic. Colonel Yasuhiko Kuro, commanding the 47th Sentai, which was equipped with Nakajima Ki-44 Shoki interceptors, led the defense of Tokyo against B-29 raids in early 1945. Occasionally, he encountered P-47N escorts from Iwima, the ultimate variant of the Thunderbolt, with increased fuel capacity for long Pacific distances. The Thunderbolts displayed performance that exceeded his interceptors, climbing to altitudes where the Ki-44's engine struggled. While the turbo-supercharged R2800 with water injection maintained full power, Kuro reported to Imperial General Headquarters that the Imperial General Headquarters that the Americans had created a fighter capable of escorting bombers for thousands of miles and engaging in high-performance combat at any altitude. Lieutenant Yoshio Yoshida of the Imperial Japanese Army Air Force's 64th Sentai, flying a Kawasaki Ki-61 Heen powered by a liquid-cooled engine similar to the German DB601, encountered upgraded P-47s over Formosa in January 1945. The Thunderbolt, with its longer wing, more fuel capacity, and full water injection system producing 2,800 horsepower, displayed performance that exceeded anything in the Japanese inventory. Yoshida watched in disbelief as what he had been told was a sluggish American fighter suddenly displayed remarkable climb performance and speed that his Ki-61 couldn't match. Yoshida barely escaped by diving into cloud cover, later writing in his diary that the Americans had created a monster that defied the laws of aviation physics. Captain Satoshi Yamada of the 85th Sentai, flying the new Ki-84 Hayate, considered Japan's best fighter, engaged P-47s over Okinawa in April 1945. Confident in his fighter's excellent performance, Yamada expected to have the advantage over the massive American aircraft. However, he was surprised to encounter a transformed opponent that could match his climb, exceed his dive speed, and absorb tremendous damage from his 20mm cannons while returning devastating fire from 8.50 caliber machine guns. Yamada, watching in disbelief as a Thunderbolt he had damaged with cannon fire, continued to climb on water injection, black smoke streaming from its engine, still maintaining pursuit until Yamada exhausted his ammunition and was forced to flee. The impact on German morale was devastating. Pilots who had once enjoyed a technical advantage suddenly found themselves facing superior American fighters in ever-increasing numbers. The psychological effect was amplified by the Thunderbolt's terrifying appearance when operating with water injection, the engine trailing thin wisps of vapor that resembled steam. While the sound shifted from the usual radial engine roar to something almost supernatural, a howling that veteran German pilots described as the sound of death approaching. The massive American fighters were no longer lumbering bomber escorts but predatory hunters that could match any Luftwaffe fighter in vertical performance. The strategic implications were far-reaching. Transformed Thunderbolts could now provide effective bomber escort all the way to Berlin and back. They could climb to intercept high-altitude German fighters that had previously operated with impunity above 30,000 feet. The water injection system maintained power at altitudes where normally aspirated engines struggled, while the paddle blade props bit into the thin air with unprecedented efficiency, enabling P-47 squadrons to establish high-cover positions that German fighters could no longer exploit. This fundamentally changed the dynamics of the strategic bombing campaign. By the spring of 1944. All P-47s in the European theater were equipped with water injection and paddle blade propellers. Interviews with pilots from multiple fighter groups confirmed that the transformation was complete across the entire force. From the 8th Air Force in England to the 9th Air Force on the continent and the 12th and 15th Air Forces in Italy. Major Glenn Duncan, a rangy, aggressive Texan who would later become a triple ace with the 353rd Fighter Group, pioneered using the P-47 for strafing and dive bombing German positions. In March 1944, Duncan persuaded his commanders to authorize an operational evaluation of the P-47 for this new role. A fast, low-level strafer, the P-47 Thunderbolt demonstrated that its robust construction and powerful engine made it ideal for ground attack missions. The water injection system provided the necessary acceleration to escape heavy flak concentrations, while the paddle blade propellers gave it the climb performance to quickly gain altitude after low-level attacks. The captured German pilot was cocky and boastful, having just parachuted into an American airfield at Y-34, a few miles from Metz, France. The base was now lit by fires from burning Republic P-47 Thunderbolts, a sprinkling of bright torches amid the gray January gloom and dirty white snow. It was January 1, 1945, and the Luftwaffe had just launched a surprise morning air attack on the 365th Fighter Group's base, known as the Hellhawks. Operation Bodenplatte, or B-2, was a desperate attempt by the Luftwaffe to gain air superiority during the Battle of the Bulge by destroying Allied aircraft on the ground. Nearly 1,000 German fighters and bombers struck Allied airfields across the Low Countries in France, destroying almost 500 Allied airplanes in the largest Luftwaffe operation since D-Day. However, the operation failed to achieve its objective. Even with hundreds of aircraft destroyed on the ground, American industrial capacity replaced them within days. More critically, the Luftwaffe lost irreplaceable pilots, experienced aviators who could never be replaced. The transformation of the P-47 meant that even when German pilots achieved surprise and caught American fighters on the ground, the aircraft that survived and got airborne could pursue and destroy them with unprecedented effectiveness. The water-injected Thunderbolts climbed rapidly, catching German fighters as they withdrew, turning what should have been a German victory into a Pyrrhic disaster that bled the Luftwaffe white. The P-47M was the faster production version of the Thunderbolt, achieving that speed by using the Pratt & Whitney R2800 engine with a CH-5 turbo supercharger. At full boost, this engine could provide 2,800 horsepower, giving the P-47M a top speed of 473 miles per hour at 32,000 feet. This represented an improvement of 50 miles per hour over the P-47D. A total of 130 P-47Ms were built and deployed to the 56th Fighter Group near the end of the war, specifically to counter the new German V-1 flying bombs and jet fighters like the Me-262. Although the V-1 threat had largely passed by the time the M models arrived, They proved devastatingly effective against conventional Luftwaffe fighters. Their superior speed and climb rate made escape virtually impossible for German pilots. The fastest Thunderbolt variant was the P-47J, which did not go into production but demonstrated the ultimate potential of the basic design. On August 4, 1944, this aircraft reached a level speed of 504 miles per hour at 34,300 feet using an R2800 engine producing 2,800 horsepower at war emergency power. The aircraft had a climb rate of 4,900 feet per minute at sea level, reaching 20,000 feet in just 4 minutes and 15 seconds, and 30,000 feet in only 6 minutes and 45 seconds. This performance exceeded anything the Luftwaffe could field, showcasing what American engineering could achieve when given the resources and industrial capacity. Production plans for the P-47J were shelved in favor of another development, the Republic XP-72, and the new generation of jet fighters being developed. However, the J model proved that the basic Thunderbolt design, when pushed to its limits, could match or exceed the performance of any piston-engine fighter in the world. Lieutenant Colonel Hubert Zena, commanding the 56th Fighter Group, experimented with new tactics to maximize the water-injected Thunderbolt's capabilities. One such tactic was the Jinky fan, in which independent flights scattered in front of bomber formations to cover as much sky as possible, maximizing the chances of intercepting German fighters before they could reach the bombers. This tactic worked because the transformed Thunderbolts could now engage German fighters at any altitude and in any maneuver. The water injection gave them the climb performance to pursue vertically. The paddle blade props provided the acceleration to close quickly, and the robust airframe allowed them to absorb battle damage and continue fighting. On December 16, 1944, the Germans launched their surprise attack through the Ardennes, beginning what would become known as the Battle of the Bulge. Hitler and his senior generals had planned the offensive for winter, hoping the weather would prevent the Allies from using their overwhelming air power. However, the airmen flew whenever weather permitted, spotting targets and getting back into the fight. P-47 pilots of the 9th Air Force fought their war up close and personal, eyeball to eyeball with German troops, vehicles, and guns. The water injection system gave them the power to escape heavy flak concentrations, and the paddle blade propellers provided the climb rate to rapidly gain altitude after low-level attacks. The rugged construction of the Thunderbolt allowed it to absorb tremendous ground fire and continue flying. During the Battle of the Bulge, P-47 squadrons flew whenever the weather allowed, attacking German armor, supply columns, and troop concentrations. The Thunderbolt proved to be perhaps the best ground attack aircraft fielded by the United States, combining heavy armament, robust construction, and the performance needed to survive in the most dangerous environment a pilot could face. From D-Day to V-Day, Thunderbolt pilots claimed to have destroyed 86,000 railroad cars, 9,000 locomotives, 6,000 armored fighting vehicles, and 68,000 trucks. The statistics told the story of the transformation brought about by water injection and paddle blade propellers. These modifications provided the P-47 Thunderbolt with the climb performance it had always lacked, making it capable of escaping after low-level attacks and catching German vehicles attempting to flee. The Battle of the Bulge marked the final desperate effort of the Luftwaffe, which, despite being conserved for one last push, still proved capable of striking when least expected. However, the transformed Thunderbolts made even this final gamble costly. American pilots used their superior performance to pursue and destroy German fighters whenever they appeared. The water injection systems enabled them to maintain pursuit through any maneuver. Lieutenant Colonel Francis Gabreski, the top-scoring U.S. Army Air Force fighter pilot in the European theater with 28 victories, flew water-injected P-47Ds with the 56th Fighter Group throughout 1944. Gabreski later noted in interviews after the war that the paddle blade, propellers and water injection transformed the Cessna Thunderbolt from a good fighter into a great one. The modifications gave the aircraft the climb performance it had always needed, enabling pilots to engage German fighters on equal terms at any altitude. Gabreski himself was shot down on July 20, 1944, after his propeller struck the ground during a low-level strafing run. However, his previous successes demonstrated what an experienced pilot could achieve with the transformed Thunderbolt. The numbers told the final story with brutal clarity. P-47 pilots claimed over 7,000 aerial victories in Europe, alone while maintaining a 4.6 to 1 kill ratio. These statistics would have been impossible without the transformation brought about by water injection and paddle blade propellers. The modifications turned what had been a mediocre energy fighter into a dominant force that could engage any Axis fighter on equal or superior terms. German, Italian, and Japanese pilots, who had initially dismissed the Thunderbolt as a lumbering ground attack aircraft, learned too late that American engineers had awakened a sleeping giant. The P-47 was now capable of matching its legendary dive speed with climb performance, creating the ultimate fighter bomber that would help ensure Allied victory in both Europe and the Pacific. In the European theater, P-47 pilots destroyed more than 7,000 enemy aircraft, over half of them in air-to-air combat. The rest were destroyed during dangerous ground attack missions, with the Thunderbolt likely being the best ground attack aircraft fielded by the United States. The aircraft's ability to absorb tremendous battle damage and still return home became legendary. Its sturdy construction and air-cooled radial engine enabled the Thunderbolt to withstand hits that would have destroyed other fighters, while the water injection system gave pilots the power needed to escape dangerous situations. The paddle blade propellers provided the climb rate to rapidly gain altitude and safety. Of the 15,683 P-47s built, approximately two-thirds reached overseas commands. A total of 5,222 were lost, with 1,722 in accidents unrelated to combat. The Thunderbolt flew over 500,000 missions and dropped more than 132,000 tons of bombs. P-47s were lost at the exceptionally low rate of 0.7% per mission, a testament to the aircraft's rugged construction and the performance advantages provided by water injection and paddle blade propellers. Pilots achieved an aerial kill ratio of 4.6 to 1, showcasing the aircraft's effectiveness in air-to-air combat once the climb deficiency was addressed. The legacy of the P-47's transformation extended far beyond World War II. The lessons learned from the water-methanol injection system influenced the development of jet engines, where water injection was used to boost thrust during takeoff. The paddle blade propeller demonstrated the importance of matching propeller design to specific power plants and mission profiles, influencing propeller development for decades. But perhaps the most significant legacy was the demonstration that systematic improvement could completely transform an aircraft's capabilities. The P-47 didn't start the war as the best fighter, but through continuous refinement and the willingness to implement major modifications, even on aircraft already in service. American engineers turned it into one of the most effective fighters of the war. The transformation was complete and irreversible. Thunderbolt pilots had written their names in history with the scream of water-injected engines and the thunder of 8.50 caliber machine guns. The aircraft that German pilots had once dismissed as too heavy to be dangerous became the fighter they feared most. The lumbering bomber escort had become the apex predator, sweeping the Luftwaffe the skies. For the German pilots who faced the transformed Thunderbolts in the final year of the war, the experience was psychologically devastating. They had been trained to exploit specific weaknesses in American fighters. Tactics that had worked for years suddenly became death traps. The comfortable climb advantage that allowed German pilots to escape at will vanished overnight, replaced by the terrifying reality of American fighters that could follow them anywhere. Halderman Heinz Behr, who survived the war with over 200 victories, later admitted in interviews that the transformed P-47s changed everything. The Germans had always known the Thunderbolt was rugged and heavily armed, but those advantages had been offset by its poor climb performance. Once the Americans fixed that single deficiency, the Thunderbolt became one of the most dangerous opponents in the sky. Major Gay R., another veteran who survived the war, also acknowledged that the transformed Thunderbolts had fundamentally changed the balance of air combat in Europe. In his memoirs, a German pilot echoed the shock of discovering that Thunderbolts could now follow the Messerschmitts in a climb. This realization marked the moment when German technical superiority had evaporated. The psychological impact was as devastating as the tactical consequences. German pilots began to lose confidence in their ability to escape when missions went wrong. And this loss of confidence rippled through the Luftwaffe, contributing to the collapse of German air power in the final year of the war. Pilots who had once pressed their attacks knowing they could escape if necessary now hesitated. This hesitation often proved fatal. The transformation of the P-47 didn't just change the aircraft's performance, it changed the entire dynamic of air combat over Europe. The industrial statistics highlighted the scale of the American achievement. Republic Aviation's production facilities in Farmingdale, New York, and Evansville, Indiana, churned out Thunderbolts at an ever-increasing rate. By early 1944, water injection and paddle blade propellers were standard on all aircraft. These modifications required only minor adjustments to the production line, demonstrating the value of good initial design that allowed for future improvements. Meanwhile, German aircraft production struggled under the pressure of Allied bombing, material shortages, and increasingly desperate efforts to develop wonder weapons to turn the tide. Messerschmitt and Focke-Wulf factories operated under constant threat, with workers laboring in dispersed facilities and underground bunkers. Quality control suffered as experienced workers were drafted into the military. The Germans understood the technology behind water injection and had even experimented with it before the Americans implemented it, but they lacked the industrial capacity and resources to deploy it widely. Their MW-50 system worked but had production problems and complex implementation that limited its use. While the Americans equipped thousands of fighters within months, this industrial disparity, more than any other factor, determined the outcome of the air war. The Americans could identify a problem, develop a solution, test it, refine it, and implement it across an entire fleet of aircraft. While German engineers were still writing reports and requesting resources that would never come. The transformation of the P-47 Thunderbolt through water-methanol injection and paddle blade propellers stands as one of the great engineering feats of World War II, not because it represented breakthrough technology. Both components were relatively straightforward implementations of known principles, but because it demonstrated the power of systematic improvement and the advantages of overwhelming industrial capacity. The Germans had better individual pilots, better tactics developed over years of combat, and, in some cases, better aircraft designs. But they couldn't match American industrial production. They couldn't implement improvements across their fleet, nor could they replace losses quickly enough to maintain numerical parity. The transformed Thunderbolt became the symbol of this industrial advantage. The aircraft showed what American engineering could achieve when given the resources and freedom to implement improvements. Every German pilot who faced a water-injected P-47 was not just facing an aircraft, but the full weight of American industrial might. And in the end, that made all the difference. The sleeping giant had awakened, and the thunder that followed echoed across the skies of Europe and the Pacific. The roar of 2,800 horsepower engines drowned out the last desperate cries of the Axis air forces. Luftwaffe pilots, who had once confidently exploited the Thunderbolt's weaknesses, learned the hard way that American engineers could fix problems faster than German pilots could exploit them. The transformation was complete, irreversible, and ultimately decisive. The P-47 Thunderbolt, once dismissed as too heavy, too sluggish, and too limited in climb performance, had become the fighter that swept the Axis from the skies. Not through revolutionary new technology, but through systematic improvement, industrial capacity, and the willingness to continuously refine and enhance an already successful design. The legacy of this transformation lives on in every modern fighter aircraft, in every turbocharged engine, and in every carefully optimized propeller blade. The lessons learned during those desperate years, when American engineers raced to give their pilots every advantage, when ground crews worked through freezing nights to install new propellers and water injection systems, and when pilots pushed their aircraft to the absolute limits, demonstrated that wars are not won just by individual acts of courage or tactical brilliance, but by the sustained application of industrial capacity, engineering innovation, and the relentless pursuit of improvement. The German pilots who faced these transformed Thunderbolts understood this truth in the most visceral way possible. They watched their comfortable tactical advantages evaporate in clouds of water-methanol vapor and the scream of paddle blade propellers clawing for altitude. In the end, the story of the water-injected Thunderbolt is the story of American industrial might. Applied to the problem of air superiority, it's a story of engineers, mechanics, and pilots working together to transform a good aircraft into a great one. A story of systematic improvement overcoming tactical excellence through sheer determination and unlimited resources. The thunder that rolled across the skies of 1944 and 1945 was not just the sound of powerful engines and heavy machine guns, it was the sound of inevitability, the sound of an industrial colossus awakening to its full potential, the sound of an empire's doom written in contrails and gun camera footage. The Luftwaffe pilots who heard that thunder knew, deep in their hearts, that the war was lost. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now. And don't forget to subscribe.